984. Between which two whole numbers is each of the following square roots? To which whole number do you think it is closer? Estimate the value of the square root to the nearest tenth. You may find it helpful to create a list of whole numbers from 1 to 17 and their squares to use with this kind of problem. So, first of all, what they mean when they say you may find it helpful to create a list of whole numbers from 1 to 17 and their squares to use with this kind of problem, it just means that we are going from, let's say, the whole number and its square. So if you wanted to, you could start at 1, 2, 3. So 1 times 1, or 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So on and so forth, all the way up to 17. So they're just saying that could be helpful for you with this type of problem. And I would suggest writing that out. It won't take very long, and you can use your calculator to help you with that. You should probably know most of them. All right, so what we need to do is we need to figure out between which two whole numbers is each of the following square roots. And we are estimating to the nearest tenth. So let's take a look at A. They give us the square root of 40. Well, I know that the square root of 40 is going to be, I know 36 is a perfect square, so the square root of 36 is 6. Then I also know that the square root of 49 is 7. Then you do want to make sure that you're writing this all down as well. So it is between 6 and 7. Now, 40 is a little bit closer to 6 than 7, right? Because the square root of 36 and the square root of 40, there's only a difference of 4 between these two. And then the square root of 40 and the square root of 49, there's a difference of 9 between these two. So, what I'm going to do is, if I'm estimating, I'm just going to say, all right, let's make this an estimate of, let's say, 6.4. So it is a little bit closer to that 36. So I'm going to say that it is about 6.4. And again, you do want to make sure that you have all of this written down on your paper as well. The next one, part B, gives us the square root of 95. So, square root of 95, I know that I have 9. I know 81 is a perfect square. The square root of that is 9. I also know that 100 is a perfect square, and the square root of that is 10. So the square root of 95 is going to be between 9 and 10. Now, you'll see that it is really almost equidistant between 81 and 100, between those two perfect squares. So, it is a difference of 5 here and it is a difference of 14 here. So I guess it's not really equidistant, but it is definitely closer to the 100. It's only 5 off. So I'm going to say I'm going to put my estimate at about 9.6, 9.7. I'm going to say 9.7 for this one. All right, again, we're going to move on to part C here. So part C is the square root of 3. Well, I know square root of 1 is 1, right? Because 1 times 1 is 1. And I know 4 is a perfect square, and the square root of 4 is 2, because 2 times 2 is 4. So this has to be between the numbers 1 and 2. Now, 3 is a little bit closer to the perfect square 4 than it is 1, which means my tenths, it's going to give me a higher number of tenths that I have to add on. So I'm going to estimate that this is around 1.7. All right. Moving on to part D. Okay, for D, they give us the square root of 59. Now, I do know that 49 is a perfect square, and the square root of 49 is 7. I also know that 64 is a perfect square, and the square root of 64 is 8. Now, 59, there's a difference of 10 between 49 and 59, and a difference of 5 between 64 and 59. So this is closer to that perfect square of 64, which means that its square root is closer to 8 than it is 7. So I'm going to make an estimate for this one of 7.6 or 7.7. I'm going to say 7.6. All right. Oh, and we also need to say that it is between the whole numbers 7 and 8. All right, let's take a look at E now. So E, they give us the square root of 200. So the square root of 200. Now I know for this one that it is, we have, the closest perfect square is going to be, let's see, it's going to be 196. That is a perfect square. And the square root of 196 is 14. And then the next closest square that would be above 200 is going to be 225. Now, the square root of 225 is 15. So we know the whole numbers that it falls between are, we're going to say it's between 14 and 15. Now notice the difference between the square root of 200 and the square root of 196 is only 4, whereas here we have a difference of 225. So we're a lot closer to that perfect square of 196th than we are 225. So it's going to be we're going to have a square root that's slightly above 14. So I'm going to say 14.1 or 14.2. I'm going to try 14.1, see what we get. And finally, part F, they give us the square root of 154. And I know that the square root of 154 is, let's see, the closest perfect square below it is 144. And the square root of that is 12. And then the other closest perfect square is 169. And that square root is 13. So again, this is, having these numbers, these perfect squares on hand is going to be really helpful for you in this type of problem. So, for me, somebody who's been doing this for a long time, I do know a lot of these in my head. And even if you were to memorize the perfect squares, that would be extremely helpful to you. But I think as long as you have a list of perfect squares, this will be very helpful for you. All right, and we have finally part F. Oh, I'm sorry. What we need to do is, so we're going to say that it falls between the whole numbers 12 and 13. You'll notice that we have a difference of 10 between 154 and 144, and a difference of 15 here. So it's pretty close. Now it is closer to the perfect square 144. So for my estimate, I'm going to say, let's say about 12.4. All right, so now we have our estimates, and I hope that you wrote down everything that I did, even though I'm erasing. You do need to make sure you have all of that in addition to these estimates. Now, these estimates will not be enough, so if you did not write down all of the things that I wrote down, you need to go back and make sure that you do that as well. Now, part G says to describe your method for estimating the approximate value of a square root when the number is not a perfect square. Check each estimate for parts A through F on a calculator. So first things first, let's go ahead and explain or describe our method. So part G, what we did to come up with these estimates is we found two perfect squares that the number we're finding of the square root is between. So we're going to find two perfect squares the number So again, our first step was to find the two perfect squares. The number we were finding the square root of is between. So for instance, in part A, we knew that the two numbers it was between were 6 and 7 because the perfect squares would be 36 and 49. The next step is to identify. So we'll say next, identify which we're going to say which whole number it is closest to. And then finally, the square root will be between those two numbers. So again, we just kind of use logic to determine, all right, now the square root of 40, is it going to be closer to the square root of 36 or the square root of 49? Well, it's slightly closer to the square root of 36, which is where we got 6.4. So it wouldn't make sense to do something like 6.9 because that would mean it would be closer to that perfect square of 49, which is 7 squared. So that's how we determine what tenth it might be closest to. All right, and we are not done yet. So you do need to make sure that if you don't have the exact explanation that I have, that's okay. You can explain it in your own words, whatever makes sense to you. But you need to make sure that you have an explanation down because that's what the question is asking. Now, there is another part to part G here. So we did the explanation part. Now it says to check each estimate for parts A through F on a calculator. So what that means is I'm going to take my estimate for part A, which was 6.4, and I'm going to do, in my calculator, I'm going to put in 6.4, and then squared, and then enter. So 6.4 squared gives me 40.96. So that, that's a little bit closer to 41. So I'm thinking that, we could adjust our estimate a little bit. So let's try, given that that's a little bit far off, I want to try 6.2 and see where that gets us. So let's put that into our calculator. 6.2 squared. Let's give that a try. Well, 6.2 gives us 38.44, which is even more off. So we might have been all right with our 6.4, but let's try 6.3 just to see. So we're going to put 6.3 squared into our calculator, and it gives us 39.69, which is a lot closer than that 6.2 or that 6.4. So A works out pretty nicely if we're rounding to the nearest tenth in our estimate. All right, B, we made an estimate of 9.7. So to check that, we're going to do 9.7 squared, enter into our calculator, and that gives us a number of 94.09, which is really quite close to the square root of 95. So this is what we should have for our numbers here, and it should be close to our square root. So 94.09, that's pretty close. If anything, I'd say try 9.8 squared. It does give us 96.04, so this is actually closest. So we are good with that estimate of 9.7. All right, part C, we had an estimate of 1.7. So to check that in our calculator, we're going to do 1.7 squared button, enter 2.89. that works quite nicely. D, we have 7.6. So to check this, we're going to put 7.6 squared into the calculator, and we get 57.76. I'm wondering if we can get a little bit closer with this one. So I want to try 7.7. So let's do 7.7 in the calculator squared. That gets us to 59.29, and that is closer. So an estimate of 7.7 is going to be the best choice for this problem. And again, it gave us 59.29. Part E, our estimate was 14.1. So we're going to put 14.1 squared into the calculator. When we do that, we get 198.81. I'm wondering if we can get closer though, so I do want to try 14.2. So I'm going to put 14.2 into my calculator. Squared, it gives me 201.64, which is a teeny bit closer. So I'm going to switch over to 14.2, which does give me that 201.64. Now it's ever so slightly closer. 14.1 would also be really quite close. All right, our last one is the square root of 154. So our estimate was 12.4. So I'm going to put 12.4 squared into my calculator, which gives me 153 and 76/100ths. I don't think we're going to get closer than that, folks. So we are good with our estimate of 12.4. All right, I know this is a little bit tricky, especially this estimating to the nearest tenth. So please make sure if you have questions to send me an email or ask on Google Classroom. And this is all for 984.